Hi, so this next series will be on simultaneous equations. So, quick talk about simultaneous equations. I mean, the most important thing really what we're doing is we're solving simultaneous equations. How do we solve them? That's the tricky bit. Now, we're used to solving just regular equations. Okay, so if someone says, say if someone said we've got, 3x plus 2 is equal to 14. We know that okay, we can rearrange this. 3x 12, if I take away 2 from both sides, divide both sides by 3, x is equal to 4. Check you've done it right by taking your 4 and substituting it in here. 3 times 4 is 12 plus 2. Okay, nice one. And we're doing BODMAS in reverse. You do your adds and subtracts, then you do multiply and divide. You're going back the way. So that's what we were doing for regular equation. We can solve this because there's one unknown and we have one equation. If we have two unknowns, so say something like 4x plus 3y is equal to 12, we can't solve that because we've got two unknowns. We need to have 6y equals 18. I've made this up. This point wouldn't solve. We need to have two equations. So we need two equations to solve two unknowns. So this is what we've been doing before. This is the kind of new skill, and it's how we solve these equations. That's the tricky bit. Okay. So let's see what in there. What are they? This is what they're not. This is just it's not a simple one. So what are they? So it's two equations effectively. Simultaneous equations is two equations. And when we manipulate those equations to solve the two unknowns, the main method is elimination, but I'll just quickly talk about substitution method. So if we have something like y is equal to 4x plus 2, and we also have y is equal to 3x, let's say, plus, or just 3, let's go for plus 4, let's say that. Yeah, we can put these equations equal to each other because if y is equal to this bit over here, and it's also y is equal to that bit over there, what we're saying is, all right, well, in that case, I'll take this and I'm going to put it in place up here instead of that y. So I'm saying 3x plus 4 is equal to, 3x plus 4 is equal to 4x plus 2. And then you just rearrange to make x the subject. So 3x is equal to, so I'll take away 2 from both sides, so 2 and 4x, and then I'll take away 3x from both sides. So 2 is equal to x is equal to 2, and then you would take your 2, substitute it into the equation. Well, y is going to have to be equal to 10 then, because y is equal to 4 multiplied by your x plus your 2. And if you sub that into both equations, that should work. So that's one method of doing it, where if you know what a y is, or also if you know what an x is, you can substitute the formulas in. So if you've got y is equal to 6x plus 4, and you know that x is equal to 7y take away 2, you can take this and put it in place of that variable, because if x is equal to this, well, I'll just sub it in there. And what that does is it gives you equations. If we do that, you see that the equation now has just got one variable, and just one. That's all we can solve, just one variable. So we're trying to get our equations down to just one variable. The most common way of doing it is elimination method. And that's what we're going to do in the video. We'll show most of the elimination. There's not many substitution methods, but it's elimination. And all we're doing is we are manipulating equations so we can add and subtract them together. That's it. But this is the most important one. Okay, I'll just underline that's the most important one. That's what we're going to go through the video. As a little side, what are we doing? We do simultaneous equations. Well, we're actually looking at where two straight lines meet, if you want to think on it that way. These are all the equations of straight lines. So don't be confused if you see something like, this and this, and it says where do the lines meet? Where do they meet? That's our simultaneous equations. Okay, this line might have this equation, and this line might have this equation, and we're saying, well, what's that point at which they meet? Okay? There's one solution where these lines meet, where the x and the y values are the same. So just watch out for that as well. But the elimination thing is what we're really, really focused on. And we do the substitution and the elimination to get us into this stage at the end. Okay. Right. So let's just start. We should get through these reasonably quickly. So just do some past papers together. So, solve. And the first thing I would do, this is elimination method, I would say, okay, this is equation A, and this is equation B. Being nice and neat is what's going to get you the marks in this. And what we need to do for the elimination method is to make sure that the x or the y's are the same in both equations. Because right now I can't really do much with this. But if I can make the x's or the y's the same, I can add or subtract the equation and solve. So what that really means is I'm going to times this equation by 6 and this equation by 4, or I could times this equation by 2 and times this one by 5. So you're times in the equation by the other coefficient. Okay? So here that's a 4 and that's a 6. I'm timesing this one by 6 and this one by 4, or do it for the y's. This one times by 5, this one times by 2. And that's so we get the same number in front of our x's and our y's. So I think I'll go with the easy one. I'll go with the y's just because the numbers are smaller. Over here, I'm going to write 2 times A, and I'm going to write 5 times B. My new equation up here, that's going to be 8x plus 10y is equal to negative 6. So see, I've taken every term and times them all by 2, so now I've got 10y. I'll do the same again with the b, this time I'm timesing it by 5. So 6 times 5, give me 30x, take away 10y is equal to 25. And you see now why we've done it. Look, these terms are the same. If these terms are the same, we can treat this almost like a really big chimney sum. I'm just going to draw in just an imaginary chimney sum where I'm going to add, this is like my, my units, my tens, my hundreds, okay, everything's in a big column. We're just going to add these two equations together, and I'm adding them together because these signs are different. If I add them together, the y's comes out as 0, which is what I want. Because now I've got 38x equals 19. And I can now solve that. I've got one term. So when I added these things together, I added all that together for 19. I add these together, they cancel out. I add these together for 38. And now I'm saying, okay, well, x has to be equal to a half because I'll divide that by 38. That becomes a half. 38 halves are 19. To get your y, substitute it back in. Let's do equation A. Substitute in, I've got 4. And instead of x, I'm going to put a half plus my 5y is equal to negative 3. So 4 halves are 2 plus your 5y is negative 3. I want y on its own, so I'm going to get that 2 to the other side. Well, that looks good. So y is going to be equal to negative 1. All I was doing there, I'll do a method line. I was doing it quite quick. Took away 2 from both sides, and then divided both sides by 5. After substituting in, I'll say that substitute. But that's the new skill, is knowing how to manipulate your formulas so that you're able to perform this procedure where you've got one variable left. Because I can't look at this and know what x and y are. But I can at this point. Well, x has to be a half, doesn't it? 38 times a half is 90. Do that. So just knowing to multiply by your other coefficient. The coefficient's the number in front of the variable. So this one here, I could have times it by 6. And I could have times this one by 4. And that would have given me 24x in front of the x. And because they're both positive, I would have taken them away. Let's try another one. Try one. I'll do this quickly because I've got a minute to go. So let me do this one. I'll not speak. See if you can follow what I'm doing. I think actually I'm really going to run out of time. So you know what we'll do? We will carry this video on the next video. And what's that? 5 times 17. 50. Last time I should have probably said that was me adding them. This time I'm going to take them away. Okay, so we'll continue this on in the next video. X is obviously equal to 7.